90 makes sum divisible by p. So we are giving a number nums, and we have another number p. So this number is just an array, and this p is just an integer. And we want to return the length of the smallest subarray that you needed to remove. Yeah. So we want to return the length of the smallest subarray we needed to remove. Otherwise, we're gonna return -1. So this remove just means if we can remove a number, for example, we're gonna remove this number 4. So this is a continuous subarray. We're gonna remove this 4. So the sum of them, 3 plus 1 plus 2, it is 6. So 6 is divisible by this p, because p is also 6. And this subarray is the minimum. So we're gonna return 1. We can also remove 3 and 1 together. It is also okay, but the length is 2, but we need to return the minimum, so we're gonna return this one. So how can we solve this kind of problem? Let me just copy the array. Yeah, so normally for this kind of array, we need to get the values. So for example, we need to get the values like from this position to another position. We need to check if that is divisible by p. Normally we need the prefix sum. So for example, we're gonna need 3. I'm gonna prepare a leading 0. So I'm gonna have 3, 4. So this is the prefix sum, 8 and 10. So if we have a prefix sum array, so it's gonna be like this, and we want to get the result divisible by p. P is 6. So for example, this number is 10, and 10 minus 4, it is 6, and 6 is divisible by 6, so it is okay. So it means the longest nums should be, the length should be 3 from here to here. But for this 3, the length is just 1, so it means we're gonna return a 1. Yeah. So we can also find other cases. Maybe this 10 minus 4. Yeah, let me think. This 10, this 10 minus 4, it is okay. Yeah, but we can also remove it in the middle. So for example, we can also remove this 4, but we can also use prefix sum. So this example is just like, so from here, this is 8, and this is 4. So 8 minus 4, we get a 4. The total sum is 10. So it means this 10 minus 4 is also 6. Yeah. So this is just we take a number in between, in the middle of the nums. So like 8 minus 4, so the result is 4. 4 is also okay. So how can we solve it? First of all, we're gonna have this number 10. So this is the total sum. This 10 gonna modular the p. P is 6, so we're gonna get a number 4. So 4 is what we need to check. So if 10 modular 6, maybe if it is 0, it means it is divisible. So we're gonna return 0 because we don't need to remove anything. If it is not 0, it means we must remove some number, must remove some contiguous array inside the nums. Yeah, but how can we check the minimum? So this remainder, we're gonna name it m. So for example, m equal to 4, and then inside the prefix sum array, we need to find 2 numbers whose distance is 4. So for example, 4 to 8, the distance is 4. It is okay. Yeah. So the subarray, the length of the subarray is 1, because 4 to 8, yeah, it is just one number, so the length is 1. We can also find others, maybe divisible by 4. Let's check this one. So 4 to 0, as you can see, 4 to 0. 4 minus 0, it is 4. 4 is divisible by 4. It means this is also a possible result. Yeah, but the length is 2. But we need to get the minimum, so it's gonna be 1. Yeah, but why can we solve it like this? So this is according to the mathematical formula. So if we have two numbers, so for example, a is bigger than b, a modular a minus b modular m equal to 0. So what we can get? So according to the modular formula, if a minus b modular m equal to 0, because for prefix sum, basically we need to calculate a minus b. Yeah, if a minus b modular m equal to 0, we can get a modular m should equal to b modular m. So this formula is used to solve the problem of this prefix sum. Yeah. So let's just try an example. So maybe a is 15 and b is 9. So modular maybe modular, let's say modular 3 equal to 0, right? Yeah, because 15 minus 9, 6 modular 3, it is 0. So can we get 15 modular 3 should equal to 9 modular 3? As we can see, it is equal because 5 modular 3, 0, 9 modular 3 also equal to 0. Yeah. So basically we're gonna use this kind of a formula to solve the problem. So if a number minus another number modular m equal to 0, so basically this means a modular m should equal to b modular m. So similarly for our example, the remainder is 4. So if a number modular 4 equal to 0, so for example, we want to get like 8 minus 4, it is 4, 4 modular 4, it is 0. So it equals to this number, so for example 4. If this 4 modular m equal to 0, right? And another number, this is also 4 modular this m 4 equal to 0. So basically means 8, the distance from 8 to 4, so the subarray is 1, is one of the possible results. Yeah. So maybe there are other numbers. Maybe we also have 5 and 9. Yeah. This may be 18, 100. It doesn't matter. Yeah. I just check this 5 and 9. So this 9 minus 5. Yeah. So if the remainder still it is 4. Yeah, this is just an example. Actually, the remainder cannot be 4. I just use an example. Yeah, if the example like this, so this 9 modular 4 equals to 1, right? And this 5 modular 4 also equal to 1, right? 5 modular 4 also equal to 1. This means a modular m equal to b modular m. And then this 9 minus 5. It is 4 modular m equal to 0. As you can see, it also meets the formula. So this means if this number modular minus 5 modular 4 equal to 0, it is also the possible result. So we can use a dictionary to solve it. So from here, this 5 modular 4, here for our question, we're going to use p. So if this 5 modular p, it is 1, and 9 modular p, if this 5 modular p, it is 1, and if this number 9 minus the remainder 4 modular p also equal to the same number. So basically we're gonna check the minimum distance. Yeah, so it is similar like 5 to 9. We're gonna check the distance. It is 1. Yeah. Now let's try to solve it. I'm gonna use the prefix sum. So I will use a list. Accumulate the numbers of nums, and initial I'm gonna prepare a leading 0. Yeah, so the initial gonna be 0. Now I want to check a value. I'm gonna define it as m. So this is gonna be the remainder. So it's gonna be the prefix minus 1. It is the total sum modular p. P is given. Yeah. So it's gonna be m. So if this m equal to 0, basically we're gonna return our final result. It's gonna be 0. Otherwise, we're gonna use this m as our remainder. Now we're gonna check. So for iv in enumerate, we're gonna check all the values and the index in the prefix array. Yeah. Now we want to store it inside a dictionary because we want to calculate the distance from I to j. So I'm gonna define a default dict as integer. First of all, I'm gonna store it. So this way, I'm gonna use modular the remainder modular m. Yeah, because this is just according to the formula. If a modular m equal to b modular m, so normally a minus b modular m equal to 0. So here we're gonna use the v modular m should equal to the index I. We just need to record the last position as index I, and then we're gonna check. So if our number is v minus the remainder. Yeah, so here it is not m, it is p. Yeah, because this p is we're gonna check if if a modular p equal to b modular p. So we need to put v modular p inside the dictionary, and we're gonna record the index. And another one, so we're gonna check if v minus m modular p inside the dictionary. So we're gonna check the minimum value. It's gonna be the result with d with v minus m modular p. Yeah, so we're gonna prepare a result. It's gonna be equal to n. So n is the length of the nums. Yeah. So this just means if we put a value v, this is just two sum. If we put a value v inside of the dictionary, maybe this v modular p. So in our example, maybe this 5 modular p, p is 4. So let's say p is 4. If 5 modular 4, it is 1. So we're gonna put 1 inside of the dictionary, and this is the index. And next, we're gonna check this number 9. So 9 modular minus m. Yeah, I'm not sure m. Maybe this m is 4. So 9 minus 4, it is 5. So 5 modular p is also 4, it is 1. So this one is also inside the dictionary. It means previously we stored this value. We're gonna get another index. Yeah, so we're gonna use this index. We're gonna use I minus the previous index to get the value. So this is why I'm gonna use I minus d v minus m modular p. This is the previous index, but I need to check the minimum because it is a prefix sum, so I don't need to use I minus j plus 1. Yeah, maybe I think this is okay. So I'm gonna check the minimum result. After that, I'm gonna return the result. Yeah, let me first check if it is okay, and then maybe try to optimize a little bit. This is for the final return. I didn't return a -1 because I didn't prepare that. So this is for if the result less than n. Otherwise, if it is equal to n, I'm gonna return a -1. Yeah, as you can see, it works. Now let me submit it to check if it can pass. As you can see, it passed and it's pretty fast. Now let's check the time complexity. So from here, this is a prefix sum, it is O(n), and this is just a dictionary, and this is O(n), and from here, it is just O1. So the time complexity is O(n). Yeah, maybe we want to optimize a little bit of about the code of the code. So from here, what is this one? This one is actually the previous index. So we're gonna name it maybe index j should be equal to this one, and here we're gonna use I minus j. This I minus j just means the prefix sum. So for example, 5 to 9. So the subarray is just 1. It is not 2 because this is a prefix sum. Yeah. For example, 9 minus 5, it is 4. Maybe it is just one number. It is just this number maybe. Yeah, this is just an example. So I think we should understand why we're gonna use I minus j. Yeah, so if it is inside, so for each of the calculation, we have to modular this p. Yeah, let me change this number m to p. So this formula, a modular p equal to b modular p, should equal to a minus b modular p equal to 0. So this is why here we're gonna prepare this value of v. This is the prefix sum of the last number. Yeah, so if this v minus m modular p inside the dictionary. So this just means yeah. So if this is inside, this just means this number v minus v plus m. So it should equal to m. Yeah. So this just means maybe this number is bigger or smaller. It doesn't matter. I think. Yeah. But definitely, if this number minus, because this is I, so I think this I should be bigger, and this v minus m is j, it's gonna be smaller. So if this v minus m, so it should be equal to m, and this m is what we calculated before, that is the total modular p, equal to m. If this is m, and this is also m, it means, yeah, definitely we find the result. So this is why we're gonna use v minus m. Yeah. And this is difficult to understand. We just need to check with the examples. Yeah, because here, basically this is the index I, the position of the I is our current index. And if we have a previously stored value inside the dictionary, so the previous stored value is v minus m modular p. So if it is inside, so basically this means for this number v minus the previous number v minus m should equal to m. If it is equal to m, it is one of our result, because our result is m. So for example, if the remainder m is 4, and if two values 9 minus 5 equal to 4, it is one of our result. Yeah, but for each of the calculation, we have to use a modular with p. Why we modular with p? Because some numbers may be very large, or maybe there's negative numbers, but by calculating this modular of p, we can avoid such kind of mistakes. Yeah. Otherwise, we cannot even check the dictionary, because inside of the dictionary, what is the value of the k? The k should be in between of 0 to p in between of 0 to p minus 1. Yeah, and let's check the value of p. Yeah, let me. Yeah, should be p minus 1, I think. Yeah, but the dictionary, the length of the dictionary is dependent on the prefix. The prefix is 10 to the power of 5, so it doesn't matter. Yeah. Yeah, but why we modular p? We modular p is just for easy calculation. So for each of the steps, we have to modular p. Yeah. But if we didn't modular p, basically, it's gonna be like this. Yeah. So if this is inside, so we're gonna check this as j, but it ain't gonna make mistakes. So this is what we, yeah, let me just try. Yeah, it passed some testing cases, but it cannot pass all the testing cases. Let's just have a check. Yeah, as you can see, it cannot pass all the testing cases because this is not right. We have to use this kind of modular p. Because, yeah, and this question is just checking if we know about this kind of a formula. Yeah, now let me submit it again. Yeah, I think I still miss something. Yeah, I still miss a modular of p. Yeah, so for each of the calculation, we have to use this modular of p. So this is according to this kind of formula, a minus b modular p equal to 0. So it's going to be a modular p should be equal to b modular p. Yeah. So that's for it. Thank you for watching. See you next time.